My name is Tzvi Skapinker. I'm the COO and VP Products at Friendly Technologies. We are a company which is dealing with TR69 and USB device management. Our journey today, we will explore the transition from TR69 to USB, especially focusing on the challenges, the opportunities, and the strategic approach of the transition from TR69 to USB, and how this shift can revolutionize the device management and unlock new possibilities that Jason has shown us clearly before when we're talking about the app enablement, service gateway, and other stuff as well. So just a few words before, for those of you who are not familiar with Friendly Technologies, we are almost 20 years, even more, in the market, started as a software company. We've been an active member of the Broadband Forum since 2006. And so we had the privilege, I would say, guiding a lot of our customers and service providers to the early adoption of TR69 and now into the new era of USB. We are very much focused on device management, as you can clearly see, for IoT and also for TR69 and USB as a unified device management platform. So let's start our journey with the evolution of TR69 to USB. I guess I just wanted, a quick walk through memory lane, and I guess you all has seen these numbers and slides before, and you are all here because you know the value of remote device management and why it actually came. Yeah, well, we are all around the same age, right? 30 something. So the main idea was we need to deploy, onboard, manage those broadband access routers. We need to maintain the device. And bear in mind, I'm using a lot of the phrase device, right? We were using customer premise equipment, the CPE with TR69, but the transition to USB is opening us the opportunity to use different type of devices. The residential gateway approach is becoming more and more interesting, carrying a lot of different applications and services. So we are looking into this as a device, and I will be repeating this until it will stick, I hope, sometime. So we need to meet the growing demand for a device management, and this is where actually TR369 or USB as we know it came in handy. But why this evolution was necessary? Okay, that was the main question. And what we can actually see is the transition from the problem that we had with speed, right? We were talking about insufficient speed to the home. And today, a lot of service providers are looking into quality of experience. That would be the next transition. So the advanced Wi-Fi management was always the key for the future of connected home, for the connected home services, but not only. There are others like Matter or even, the formerly known as Zigbee that were challenging the home network domain with over-the-top services. And so the importance shifted for onboarding new value-added services. Like we have seen before, we're talking about additional IoT services, cybersecurity, parental control, remote office, whatever service that you would like to onboard on your residential gateway. So all of this is driving us forward to establishing a new device management standard that will be much more open and flexible to accommodate everything. So USB offers the ability to manage these more complex devices, okay? That's the main idea here. and deploy value-added services more efficiently. This is becoming or we are actually utilizing the advanced USP data model that my colleagues Daniel and others will be talking this day and exploring a bit more in depth about the possibilities, the new possibilities, and the new enhancements with the new device data model. With additional communication protocols that we will touch base, and also we have the USP architecture session coming later after this afternoon, I guess, right? So we will be touching base of all of these functions to see why the evolution was necessary and how it is giving us a solution. But what were the main roadblocks for TR69? I was, trying to think out, because TR69 is working. It's serving millions of devices around the world. So we know we want to advance to value-added services and so on. But there are still some limitations with TR69 as we know them. We have some security concerns with TR69. Although we are utilizing SSL TLS for the transport security encryption, but not all implementations are utilizing this to the full extent or adequately. So there are some potential vulnerabilities. There are some scalability issues with TR69. TR69 is bounded tightly to a single ACS, right? And if you want to grow, you need to grow both in resources and server capacity and so on. So this is one major, I would say, drawback of USP. TR69 was designed initially for managing network devices, right? Routers, broadband access routers, and so on. But in today's evolving world, we see it's not well suited for the next generation of devices. We need to see much more capabilities of managing different type of devices, becoming the IoT bridge de facto at home for onboarding those type of devices as well. So in order to meet all the needs of the modern smart home and the IoT challenges, it requires a more versatile device management solution. With the progress of actually IoT and the need for more efficient and scalable and secure management solution, there is also a gradual shift towards newer protocols and standards. This is why USP is designed to overcome these limitations and be de facto the next generation device management protocol. But despite these limitations, we need to remember that USP is used widely. Someone just woke up, sorry. So USP is used widely with a lot of service providers. Some of them are here in the room. Some of them will be here tomorrow. So we are looking in a transition period. We are not looking into a cutover. This is de facto would be a transition period moving forward from TR69 to USP. So, few benefits. So we discussed a bit about the challenges that we had, right? We said that TR69 had a basic message transfer protocol. USP is delivering a new method or new methods, different protocols. Data encoding is much more efficient, and I will touch base on this and also give a bit of differences between them. Communications, we can have actually an always connected device communication for some use cases that you think might come in handy. And of course, the multi-server management, which means that you can run multiple controllers on one network, offering different type of services. of course, the enhanced security that we will also discuss a bit. So let's see this a bit more in depth. So with USP, we have introduced additional MTPs, MQTT, WebSockets, and STOMP. Protobuf for data encoding, and this is very interesting to see. I'll get there in another slide. Communication, as I said before, always on. You can have the always on communication with the device and get device status at any time. The management server is actually one of the most important things, or the multi-controller that you can have with USP. Jason was showing before the need of growing services and applications. So the only way that we can achieve that is by having multiple controllers, and each controller with a different, I would say, capacity, and even also with different use cases. Like if you want to have a Bootstrap controller that will do just Bootstrap, just on board devices, and then send the device elsewhere. If you would like to run a controller that is set for quality of experience, you need to collect information, you need to collect data. So you can actually set these controllers apart and use different type of controllers with different credentials and settings for every type of a controller. Security, like always, advances a bit slower than the threats, like always, we know that. But we've introduced DTLS, the controller trust, access list, and end-to-end application layer security as well could be incorporated as well. So TR69 actually offers comprehensive and future-proof framework for device management, addressing the needs of the increasing connected and complex digital world as we see it already. It emphasizes on security, on scalability, and flexibility. It makes a well-suited for a wide range of applications, from the traditional broadband networks into the emerging IoT challenges as well. We can easily map device capabilities and control the device settings. This will be, I guess, shown in the data model session later on today. We can easily perform device management tasks related with device lifecycle, firmware updates, software management, okay? These are all actions that can be easily achieved. We can enable both in-band and out-of-band data collection. You will see this also this day for different types of data collection methods with USP, with new events and driven from the device itself. And also we can provide the secure control and communication layer for the device. The most important is that USP offers a flexible data model that supports a variety of different, that can support a variety of different devices. And that is what makes it all possible, I think. So I will just go very highly on the standardized data model to 17, to 18, going to be 218 very soon, coming soon, so wait for it. Oh, it will be there. So USP extended the device data model with the new device 2.0 and so on, with additional also capabilities. One of them would be also the IoT capability. The main point is that we can connect various devices using a common language. And that's the main barrier when we're talking about different type of devices. We need to standardize that somehow and not just be yet another device management protocol, but we need a standard. it will be easier to onboard new devices. It will be easier to maintain them. It will be easier also to switch. We don't want this vendor lock-in anymore. We want to have the flexibility and capability of moving around for the best needs of the company, of the organization, and of our subscribers. So this can be easily achieved by exposing those new capabilities into the data model. The data model is always advancing, it's enhancing constantly, and you will see this also, I guess, in Daniel's session as well. But just a quick word, the data model structure was changed a bit. Don't get alerted. So introduced commands, events, a lot of new stuff that will make our lives easier for onboarding new devices with USP. We said that we have a new protocol stack, right? And we have new message transfer capabilities, discussed about STOMP and MQTT. You can have an always-on connection and WebSockets as well. But one of the major, I think, advances would be the protobuf use, because you can see that both protobuf and XML are formats that used for serialization of data. And it is particularly useful in communication protocols, but not only. It's being used widely. XML was designed both for human readable and machine readable, but it has some downsides as well. It is large file sizes. And here's where protobuf comes in handy. Although protobuf wasn't designed for human readable, or maybe some of us can, I don't know. But it is designed for efficiency. It is much more efficient than XML. It's much more efficient in serialization and deserialization of and speed. And it was specifically designed to reduce the overhead, resulting in a smaller size and faster processing time. But is it really true? You know? So before coming here, I asked my QA guys, run a small test, you know, using some emulated devices. Show us the difference between different MTPs and the use of a new encoding. So I asked them to run just basic use cases or operations like bootstrap or onboard request for USP. You can see the session size in kilobytes that was measured. Yeah, I know there is co-op and it was deprecated, but well, we use that. So why not test it? You know, if it's there, use it. You can see that USP is much more efficient in any operation. The periodic inform versus periodic event for USP is much more efficient. The monitoring request and response are smaller in size, which makes it much more efficient to collect data and collect a lot of data from the devices. That's our main target. We are moving away or moving ahead, I would say, to quality of experience. And that is one of the main challenges that we have. So after showing this nice data that shows how USP is actually more efficient, and we have a full session about USP architecture that will be during this late afternoon, but nevertheless, the USP agent can be controlled by multiple controllers, which may be in a service provider network. Like today you have the ACS, and you can have additional controllers operated by third-party applications. A controller on the gateway itself facing the LAN or WAN, like a smart home gateway that you need the ability to control it when you have a problem or you don't have any connectivity to the internet, so you still want your smart home to be operational. Or even you can run a microcontroller on a mobile application for different use cases. These are things to consider, and this is actually a call for action for application developers to use the controller mechanism and to integrate that with different devices for different use cases. USB can also assign different control rights for each controller, so it is much more flexible than what we had with TR69, and this is why we can use that in order to run those additional services on the network. So you are no longer tied to a single ACS, right? You can have multiple controllers with different functionalities running on the same network and communicating with the same device. No additional agents, no additional clients. You don't need to integrate anything else. Just use the USB agent on the device itself. Make sure it is integrated well, and it is quite easy to achieve. So one of the benefits I would say that USB also brings is the ability to scale for IoT. It actually acts as a bridge for the connected home and IoT devices. And you will see that also with the theory of operation in the USB data model that we have today already. USB delivers the unification for IoT and smart home devices by actually proxying the non-IP interfaces like Matter or Zigbee or whatever interface, Bluetooth you might have, and others as well. The need for a platform that could enable these service deployments more easily and efficiently, making it easier for application developers also to integrate with millions of potential customers, right? You can develop an application and you can offer this service by offering a controller that will integrate with those type of devices, which are already supporting USB. All you need is the access and someone that will orchestrate and create those services on top of the device. So we are talking right now not only about the scalability to IoT, but also about the possibility of introducing new orchestration tools within the service provider network. So if you had a standard that could communicate efficiently with any residential gateway and deploy services for various sensors without the need of a tiring integration, you will be able to send requests, get information from those devices, and that will be the role of USB and the future device management platform solutions. So we talked about the transition from actually speed to quality of experience, but a major point is data collection challenge. USB brings us the ability to both collect in-band and out-of-band information using USB events, but also using bulk operation over HTTP or MQTT, and to send this information and utilize a different collector that will be managing all of this information and collecting this data, processing this data, and analyzing different trends, and also providing a proactive approach and a seamless resolution before you have any problems or before something is happening on your network. And this is a real world application. This is being utilized today with bulk operation for collecting information. You don't need to install anything else on the device. Actually, you can utilize USB bulk operation and USB events as well in order to collect a large amount of data. But what can you do with this data, right? So you've collected that. Just a simple, I would say, example that I'm showing right now is a home score. Let's collect information from all of the devices. Let's assume that the CPU memory, LAN WAN statistics, and wireless LAN is also, we're collecting all of this information, and we can with machine learning capabilities, we can create a score for a user at home. This will revolutionize the way that service providers are actually seeing the customer as of today. It's no longer, okay, you have the speed, so SLA is fine. I don't know what's going on with your network, and we know that Wi-Fi is a challenge, and most problems are related to what happens within your home and less with what happens on the network side, right? So in this way, we can collect a lot of information. A lot of information is stored on the device. The only way that we need is actually a good way of collecting this information, processing, analyzing, and giving value-added services to the service provider. So what we need to do to navigate this transition? Well, while I'm talking with some of our customers, there are common misconceptions about the transition. It's difficult, it requires new infrastructure, it is lengthy, and of course, it is expensive, right? So on the last point, I cannot comment. We're not developing any hardware, so, but there are ways to overcome these challenges and to have a more, I would say, easy transition phase for the service providers. And here I'm still using the CPE notion, right? But it could be easily a device. What is actually important factors that we need to consider for a successful transition? What we need. Every service provider needs to maintain the provisioning procedure. He needs to continue and manage the devices that he has, support and analyze the information that he's collecting, right? These are the 4 building blocks that every service provider is looking for, also with the current TR69 solution and when he's looking into the evolution and transition phase. So this is something that we must maintain. So I try to see how we can divide this in a simple way to 3 elements that we need to take under consideration when looking into the transition phase. So first of all, device capabilities, right? We need a device. We need a device or a new device or a device update, firmware, whatever, that can support USB. We need a network to support this as well. We said we have new MTPs. We need to consider network elements, firewalls, and other elements on your network that are allowing this new device management protocol. And of course, the backend server side that will have the solution and can actually maintain and run USB as well. So basically we need to consider, and this is referring back to what Jason said at the beginning, that TR69 is there to stay, okay? It's not going to disappear, not today, not tomorrow. There will be a very long transition phase, I believe. So we need to have the interoperability working with TR69 devices. So we need to have device and network requirements for the MTP support. We need an agnostic device management for both TR69 and USB on a single platform, because otherwise it will become very chaotic and also a problem for service providers to integrate USB into their network. And we need to have an effortless, I would say, migration procedure. Okay, we need to have the ability to shut down one device, upgrade a device, and then to start up this as a USB device. And this is our challenge. This is how we are seeing this transition phase. So when we're preparing for a smooth transition to TR369 USB, we want to have 0 effort using a single device management platform. But still we have some things to consider, right? We have some technical complexity and we have a learning curve here because USB is a new standard. It has some changes. Our technical guys need to understand that, and they need to learn, they need to train, they need to see what are the new changes, and changes in data model structure, changes in the way that the device communicates, and so on. So there might be an adaptation period that will take time, and we need to train our technical staff as well. We need to integrate the USP controller into an existing environment, right? This is another challenge that we have that was designed around TR69. And this can be challenging. Sometimes we need to replace some legacy devices. Sometimes we need just to update them. As well as we need to ensure that the network can seamlessly support new USB devices. And also the backend solutions, the OSS, BSS systems at the operator network are also communicating and can integrate with our USB controller as well. We need to have a migration strategy that will actually support the coexistence of TR69 and USB devices on the same network. This is a significant challenge because service providers need to ensure that service is not interrupted during the transition phase. This would be, I'd say, the most challenging part for every service provider. So it might also involve running some parallel systems, implementing interim solutions that can bridge the functionality for both protocols. There are also some security considerations that we need to take in mind as well. Although USB is designed with modern security standards, but a transition to a new protocol requires a thorough review of the security policies of the network, ensuring that there is no harm to, and ensuring actually data privacy, and also secure device authentication, and the integrity of communication as well. The transition actually offers us also opportunity to reevaluate and enhance the security settings of the network. But it actually requires a careful planning to avoid vulnerabilities during this transition phase. The migration to USB can also involve some additional costs related to hardware, maybe. There are certain elements in the network that needs to be replaced. So this is also a part of the transition plan. You need to plan carefully also the budget for and the cost for this transition as well. USB is designed to be more scalable and efficient than TR69 by supporting a wider range of devices and services. However, ensuring that the implementation of USB can handle the expected load and perform optimally under various conditions is a challenge as well that we need to take under consideration during this transition period. This includes also testing, optimizing for different network topologies, device types, and also all the services that we want to integrate. To navigate these challenges, organizations should engage in a very careful planning, pilot, testing, and phase migration strategies. We need to collaborate with device manufacturers, with the software vendors, and industry group like the Broadband Forum in order to have, as this is it provides us actually a valuable resource and guidance during this transition phase as well. So, just a quick demo. So I've connected a TR69. This is just a demo system. I've connected a TR69 emulated device. You see, I'm the manufacturer, I'm the model. Maybe. We can see that this is with the limitations of speed, right? This is a TR69 device. We can see the hardware version, the firmware version. And specifically, I wanted to show you that we see the device data model. It's TR181. It's a basic one, maybe a bit extended, but nevertheless a basic one. We have also some pre-provisioned information, the account information that I've added in advance for this TR69 device. So let's assume that you are shipping right now a new firmware, flashing the device and asking the device to connect again with a USB agent, right? Let's see. Hope it works.
It's good to know the network's not on strike.
So you remember this is version 1, firmware version 1, and the serial number is something with a demo at the end, right? Okay. And let's assume that I've sent a firmware update request to the device. The device updated very quickly because I've shut it down and activated the same device with the same serial number with an emulated device as well. So we can see that this is a USB device. The same serial number using USB. We can see it is a different firmware, V2. It's just an emulated device that I have. We have reassigned all the provisioning data automatically, which means you have a seamless transition between TR69 to USB. You're just flashing the firmware for a device, the same model, the same serial number, everything is the same, it's connecting, just the protocol is a bit different. And all of the provisioning data is already there and associated and can be also pushed to the device. But let's see that this is really a USB device. Maybe it just said USB, who knows? Okay. So the data model looks the same, right? TR181. However, we can see the new enhancements in TR181. We can see the notion of commands, right? That we didn't had in TR69 and so on. So you can execute commands, you can set events and everything else. So this is actually a seamless transition. The same experts that were using or having or managing these devices before, we try to have the transition as simple as we can, that the look and feel will not change, but there are additional capabilities, right? You need to learn the additional capabilities of how to use this. So in this way, we just try to show the user, okay, now you can run this command, you can run this diagnostics for a device and do whatever ping test you want. I don't know if it will work. Yeah. Sometimes, a few times.
This is on the USB device right now.
Yeah. This is on a USB device. This is why we try to have it done, on the background. So the user experience will not change dramatically for those who were used to operate TR69 devices, although you have new functionalities, new capabilities as well. Okay. So simple as that. That's the only thing that I wanted to show. And again, I had some connectivity issues. I see that, like always, every good demo is stuck at the end. So, we're in good.
That's how you know it's live.
Yeah, it's live, it's stuck. And these are emulated devices as well, so there's nothing much. But we will also be, very much engaging with the Broadband Forum members as well and I know there is also a certification procedure that we're working on and having more and more devices integrated and showing them as well how they're operational and and everything. Okay, so I'm actually coming to the last slide. Some inspiring thoughts about the future, how USP can give us the ability for smarter connected homes, and onboarding those actually the value-added services that we were all referring to, and Jason showed the app enablement service gateway. This remains the main challenge for service providers, I would say, throughout the world, even today. And the need to work with different device manufacturers, chipset manufacturers, integrate with the current backend OSS systems and so on, makes it very costly and technically challenging as well. There are a lot of new and additional applications and services that we can offer for our potential customers, like service assurance, speed test, enhanced Wi-Fi, security, cybersecurity, parental control, home office, like remote working from home, also energy management and smart home solutions. So all of this can be achieved by the simple transition to USP and integrating more and more services and giving more value to our subscribers. Actually, if I remember that right, more than 70% of the responders to the Broadband Forum survey that we had last year stated that they are moving towards the any quality of experience solution. So they are in need and in a desperate need for a better, I would say, data collection opportunities and also additional value-added services that can provide additional services for their end customer. So that was all for me. I think we have a Q&A session at the end.
We have a little time. Yeah,
right?
sure. Does anybody have any immediate questions for Zvi about the experience of transitioning from TR69 to USP? Feel free to introduce.
Yes, well, my name is Mateusz Druński. I'm from Icotera, which is a residential gateway manufacturer. We are quite new to USP. And I have a question to you about this transition from being managed by CWMP to USP. You've shown, a simple task to update the firmware upgrade, and that was it. But I think that there was lots of logic behind for the controller discovery.
Yeah.
So it's usually with the DHCP options for the ACS URL and a relevant branch in the data model for the management server was created, right?
Yeah.
And during this transition, what was behind it? I mean, if this branch for the ACS was removed as you moved completely to be controlled by the USP, and what are the, let's say, most common scenarios for transitioning between those two protocols? If you, for example, change the data model in the newer firmware to use the USP controller instead of management server, or any other ways to achieve that?
Yep. So thank you. That's a great question. That's the biggest challenge, I think, for us as a device management platform, to have this unification or a single transition phase. And you are correct. It does require a lot of work on the backend server in order to accommodate this. You're changing the message transfer, you're changing the data model. So you need to run another discovery on the data model and retrieve all the device new capabilities. You have different capabilities with different devices, with different firmwares. And yes, this is done on the backend server. So there is a lot of the transition is being handled and carried on the back end. And what I was trying to show here is actually from the perspective of the user, of the service provider, having the same, I would say, look and feel from TR69 to USP. This is something that we are aiming to maintain. Otherwise, the learning curve would be very, very high. And also the integration of additional controller, sometimes in the network, might be very costly in the transition phase. So you're right. There is a lot of work that is being carried on the backend server, and in auto discovery procedure that we are running, we are actually assigning a new data model for that specific device, pushing also the provisioning data. You need to remember that one important thing is the provisioning data. You had a device. Let's say the device had a PPP connection with a username. You need to send this again to the device, right? So you need to re-provision the device once again. So there are some challenges on the backend server that you as a device manufacturer will not be facing them, right? So it still remains on the backend server. And you will say,
Yes.
yeah, definitely.
So my presentation after the break will touch on some of the data model differences between CMP and USB, but the point behind what Svi is saying in this presentation and what he kind of showed in his demonstration is that the majority of things about the data model are the same. There are some things that are different. Some of those things are pretty important, but you know, it's not a complete reinvention of everything, right? But to your point, something like that, some of those things are actually some of the most important things are the things that are different, but we'll talk about that.
Hi, my name is Gregory. I'm from Icotera, as my colleague. I have question regarding the backend side, because you've shown that you have application that is double stack. You can, on the front end side, you are showing the same device with different data model and different protocol. But on the gateway, for example, we need to implement two binaries, yes, two applications, one for CWMP client and one for USB, or you provide some sort of double stack application which covers all the necessary details.
So on the backend gateway, it's a unified device management platform that supports both TR69 and USB. So with also additional protocols, if you want to run, let's say, pure MQTT, but it's not designed for, it's not a structured device management protocol, right? We all know this, that MQTT is utilized mainly for the IoT domain, for managing sensor or telemetry data. So the backend server, yes, it is a unified device management platform that supports both of them. The consideration from the device, from the gateway side, the residential gateway side, whether to run a single stack or a multiple stack, it is a part of your decision with your subscribers, right? That they will be looking for, okay, we want to integrate both of them, like in the transition phase, we still have, or you want to flash one device with a new firmware and that's it. And you have actually the new USB protocol. So that is something, this is a consideration that you need to take with your subscribers, with your customers, to understand what is actually their need, if they have a dual stack need or just USB. From my perspective, if you're flashing to USB, it is backward compatible, so you can have all the functionalities that you had with TR69 and the additional functionalities that our friends here will be showing as well during today's session. So basically, it's your call what to do on the gateway side, if you want to run a dual stack or just a single one.
And Daniel's presentation that is next is actually a little bit more about the coexistence piece. So it's a great segue. Is there any other questions? I guess the only question I had, Svi, was, you know, tomorrow is going to be a lot more about the real world use cases that are out there right now. But I'm wondering if you had any feedback on what sort of, like, when you're going, you're trying to make this totally sort of transparent to the operator. But would you say is the biggest pushback that you've experienced when you're trying to be like, okay, well, you know, these are the things you can do with USB. So if your infrastructure is supporting it, these are the things we can do for you. What's usually the biggest pushback that you're getting?
Well, you know, that's a great question. First of all, they're asking for devices. This is something that I cannot provide, you know. I'm meeting with them and I'm saying, okay, guys, what is your roadmap for USP? Let's start working on this. And the second thing is to talk about value-added services, right? One major thing that we need to consider when also the device manufacturer and vendors are looking into integrating or developing USP agent for their devices is how to accommodate those value-added services. Because again, the transition is towards quality of experience. They want to run more applications on the residential gateway. They want to collect more data. I would say that today's major setback or challenge is data collection from devices. It was very difficult with TR69. It becomes much more simple with USB, but you know, we are waiting for the devices to arrive. So guys, let's go to work and let's develop them.
Okay, so one last question that came to my mind. How do you feel to use USB as, for example, one source of truth on the gateway for web UI, other applications that connect to it, or some sort of, one source of truth, for example, yeah?
I think this is actually the target for us, for all the members in the broadband forum, to have a residential gateway that you can communicate with a unification, that you will be able to onboard different, to connect different devices to your residential gateway, Matter, Zigbee, Z-Wave, if someone is still using that, Bluetooth as well. So you have a single point of contact within your residential gateway, which is the USB controller. Otherwise, all of this becomes an over-the-top services, and then you actually have to maintain some cloud-to-cloud connectivity. And we know that might be a challenge, you know, integrating between Google and AWS and Apple Home for controlling those devices. But making USB a standard for the residential gateway device management protocol and onboarding new applications and controlling them and having an orchestration solution for all of these applications, this is, I think, and you know, for looking into the future, this is what I believe our operators are looking for.
Cool. All right. Thank you, Zvi.
Thank you.